So like I said, since we introduced the I with a square root of a negative, it actually created a whole other branch of mathematics with complex numbers. So we're just going to do a little bit with it. So what it means to be a complex number, it's not complex because it's difficult. The reason why they like to use that word complex is it actually combines a real number with an imaginary number. So a complex number just has two parts to it. It has a real number part to it, so it's going to look like a normal number, and then it has an imaginary number with it, and it has an I with it. So a lot of times we just use this as a general complex number, A plus BI. So the real number is usually written first in a complex number. So it's going to just be whatever number we want it to be. It could be positive, negative, it could be decimal fraction, it could be any number, but it won't have an I. And then the second part of it is the imaginary unit, and we know it's imaginary because there's an I with it. So, like I said, this is just kind of a generalized complex number with A and B, but this is typically what a complex number will look like. You'll have the real number written first, and then behind it will be the imaginary number. And since the imaginary number is positive, we put a little plus sign in there. Now you cannot add them together, so that's why a complex number always stays separate, because we have one number that doesn't have an I, and one number that does. So we actually can't add these together, so it just stays 5 plus 2i, and this would be considered one complex number. So then what we can do with that, I can give you multiple complex numbers at once, and then you add, subtract, multiply them. There is division, but we're just going to do add, subtract, multiply today. So when we talk about a complex number, like I said, it's not called complex because it's difficult, it's just complex because there's two different parts to it. There's a part that doesn't have an I, and there's a part that does. Okay? For the most part, the operations that we use will actually pull in some stuff we've done in the past. So it should seem a little bit familiar. So when we add and subtract, we'll use some phrases that we used in the past. Like I said, now we're just applying it to a complex number. And we're gonna, like I said, we're gonna have multiple complex numbers at once. Okay. So adding and subtracting, I have it combined because really we do the same process. There's just one little small difference between the problems. When you add and subtract, you can only add and subtract likes with likes. So when you add two complex numbers together, like I said, we can't technically add the real number with the imaginary number because the real number doesn't have an I and the imaginary number does. So when you have multiple complex numbers there, we still can only put likes with likes. So if you notice the way it's written, I'm going to cover up a little bit so that way I don't get too distracted. That's just for me because I know you can see all the problems, but so here, we have one that's addition, one that's subtraction. Notice there's a very subtle difference between the two problems. The use of parentheses here doesn't always necessarily mean multiplication now, so you just have to make sure you're, a lot of people see the parentheses and they want to start multiplying because we'll talk about multiplying too. But if you notice, what they use the parentheses for is really a grouping thing. So this is saying this is our first complex number, 3 plus 5i, and this is our second complex number, 2 minus 4i. And then you look in between it and ask and you can see what you're asked to do with those two complex numbers. So since I see a big plus sign in between those two complex numbers, I'm asked to add those. And when I add those, I can only do likes with likes. So what can I add with the 3? The 2. Yep, so that's fine. And then what can I add with the 5i? Yep, negative 4. So make sure you keep that sign with it. So whatever the sign of the imaginary number is, it's whatever the signs in between it. This was positive 5i, negative 4i, so we add a positive 5i with a negative 4i. How many i's do we have? 1. Yep. So you could write 1i with it, just like before, since we have a variable there. If you don't want to write the 1, if you just want to write I, that's fine. And then since it's positive, we're just going to throw a plus sign in between it, and there's our result. Alright, so the second one, again, it's set up very, very similar. All these problems are going to look pretty similar because you're going to see parentheses to show grouping. You just have to look in between it to see what it's asking us to do. So what do we need to do with these two complex numbers? Subtract. Okay, and just like before, with adding, with subtracting, it's only like terms. Okay, so now we're going to subtract, and make sure you subtract all the way through. So the big thing to remember for subtraction versus addition, still watch those negatives. So with the 4, what can we subtract from the 4? 3, so that's 4 minus 1. Okay, so then what are we going to subtract from negative 17i? Negative 7i. Yep. So this is where you have to watch your negatives. So we take negative 17i and we're going to subtract a negative 7i. What happens if we subtract a negative?
It's more negative.
That's a positive. It turns positive. Because we have a negative here,
Oh.
and there's a negative there, so that double negative is going to make it add. So we'll take negative 17 and actually add 7i. So it's negative 17 plus 7i. Positive.
No.
Would it be positive or negative?
Negative.
It's negative because 17. And there's our new numbers. Every once in a while you might see them without parentheses, so I just want to do a couple other variations. For the most part, you're going to see it like the first two examples where you see the parentheses and then in between it you see an addition sign or a subtraction sign. Here, you might just get a whole string of things, but you're still adding like terms. So I still can't add the 4 with the 5i or add the 4 with the negative 3i. What can I add the 4 with? The 7, so that's 4 plus 7. And then I can add the i's. How many i's do I have? 2i. Since it's positive, I'm just going to throw a plus sign in between it. And there's my simplified answer. Sometimes you can have a complex number where there is no real part. Okay, sometimes you might just work with imaginary numbers. So if we have 4 minus 5i, negative 1i. Questions about adding it together? Like I said, with this, it's pulling in that like term stuff that we've talked about before. So it's pulling in some previous stuff we've used. Now we're just applying it to a complex number. So then lastly, what we're going to talk about is multiplying. With multiplying, there's a couple extra little things, but for the most part, it pulls in stuff we've done before. Because mostly you either have to distribute, or sometimes you use the word FOIL. And that's all FOIL means is that you're distributing multiple things. So you see that phrase, I'm going to distribute multiple things. Alright, so real quick before we do the examples, underneath the title here I have a little thing that's typed. There is one extra property when we talk about I, and that's whenever you have to multiply an I times an I becomes squared, okay? And I squared actually gets its own definition. Okay, whenever you see an I squared, it becomes a negative 1. So you can think of it kind of as like an automatic substitution. Whenever you see an I squared in your problem, you're going to substitute negative 1. So you're going to take the I squared out and substitute the negative 1 in there. Okay? Now I'm going to do a little bit of explanation of why that is here in a little bit. Again, you don't have to write this part down, but this is kind of where that I squared equals negative 1 stems from. So earlier last year, but earlier in this semester, when we first talked about I defined it as I equaling the square root of negative 1. Okay? So because of that definition, whenever we saw a negative underneath the square root, we could switch the negative to an I, and it stems from I being defined this way. Okay? So the reason why this I squared becomes negative 1, because if you think about squaring the definition of I, so I'm going to square both sides now, so I squared. And I have the square root of negative 1 squared. What happens if you square a square root?
It takes it away.
It takes it away, because squares and square roots are opposites of each other. So that's why, because I is defined as the square root of negative 1, if you have I squared equals negative 1, because if you square an I, you're squaring a square root, which will cancel out that square root. So that's why I squared always becomes negative 1. I was just trying to give you a little bit of an explanation of why that is. So the big thing that we're going to use I squared with, like I said, it's going to be like an automatic substitution. If you ever see an I squared in your problem, which we will because we're multiplying, and now when you multiply an I times an I, it becomes I squared. Now whenever you see an I squared, you're going to take I squared out and substitute a -1 in for it. Okay. So I just have a variety of different multiplication problems that you can see. So with this one, we see an I outside of parentheses. What do we usually do with the number or something outside this parentheses?
Distribute.
Yeah, so we're going to distribute that in. So the nice thing to remember about multiplying is it doesn't have to just be likes with likes. You multiply everything together. So when you take I times 2, that's fine. That's just going to become 2I. And now we're going to take I times a -3I. And this is where I squared is going to happen. Because if you take an I times an I, it becomes I squared. Okay? And then eventually okay. So I'm going to show this in a couple steps. Eventually, once you get kind of the hang of what I squared ends up doing, you can kind of combine some of these steps. But again, it becomes I squared because I had to take I times -3I. So it stayed -3, but then I times I became I squared. And so now, whenever you see an I squared in your problem, it's an automatic substitution. We're going to replace it with the number -1. Okay? Now it's still being multiplied here, so we're going to take 3 times -1 instead of 3 times I squared. Okay? So I squared is going to go completely away, so you're going to replace it with a -1, and it's still a multiplication. So when I do that, I can still simplify a little bit. What's going to happen here if I simplify this part of my...
It's gonna go positive.
It's going to make it a positive. So I'll have 2I plus 3. And again, we still can't add this 2I with 3 because 2 has an I, and now 3 doesn't. So once you take out the I squared, you're going to replace it with a -1. Essentially what the I squared does is it just takes that number that's attached to the I squared times a -1. So essentially what happens to it is it just changes sign. Questions about the first one? Okay. So this one, we're just multiplying two things together. So you have 4I times 3I. So we can still multiply. So what's 4 times 3? 12. And then we take I times I. I squared. Yep. So whenever we take an I times I at any point, at any time in your problem, I squared or I times I becomes I squared. And then what does I squared become? -1. So really it's 12 times -1. So how can I simplify that? Make it -12. Now, like I said, I show it step by step. Once you get kind of the hang of what I squared does, if you combine some of those steps, I'm fine. So like I said, essentially what I squared does is it takes that number and changes its sign. So you get rid of the I squared. So there's no more I with that number, but then instead of, if it was positive, changes to negative. If it was negative, changes to positive. Okay. So now we're going to do these last two. This is one where we have to, bless you, use a little bit of the FOIL thinking. Okay? Because what FOIL does is essentially if you're multiplying multiple things together, you have to multiply every single thing together. So all of these, this 2 plus 4i, will need to be multiplied with both the 9 and the -3i. So unlike with addition and subtraction, with multiplication you multiply everything together. Okay, and that's why the acronym FOIL was created, because it just helps keep track of making sure that you multiply everything together. Because you have to multiply the first two numbers together, 2 times 9, and you have to multiply the outside two things together, the 2 and the -3i. So we're going to multiply those two things together. So let's go ahead and start doing that. So it's 2 times 9, 18. Then you have to take 2 times -3i. If I take 2 times -3i, what's that going to be? -6. And we'll still have the I. It won't be squared because the 2 doesn't have an I, but 3 does. So that was our first and our outside terms. Then we need to take 4i times both of these. So we take the inside two things and multiply together. So that's 4i times 9 would be 36i. And since it's positive, I'm just going to throw a plus sign in there so there's no gap in there. But again, so I didn't have to do that with the 6i because it was negative. But if you don't have a sign, just go ahead and throw a plus sign in any gaps. And then we have to multiply the last two things together. So we need to take 4i times negative 3i. So that's 4 times negative 3. And then I times I.
Squared.
Okay. So we've done all of our multiplying steps. Now we just need to simplify a little bit. Okay? So you should be able to combine some like terms here. If you look in the middle, you should be able to combine those i's. Okay? What else can we do?
12i, 12.
Whenever you see an I squared, no matter what type of problem you're working with, what does I squared always become? Negative 1. Yep. So I'm actually going to take care of that first. Is it okay if I don't rewrite some of the stuff? So just underneath it, I'm going to write negative 12. I'm going to replace that I squared with a negative 1. What's that going to do to my 12? Make it a positive 12. So now I have an 18 and a 12. Do you suppose I can combine those two things?
Yeah.
You can. Okay. So now you should be able to combine 2 real numbers and 2 imaginary numbers. So we have the 18 and 12 that we can combine, and we have the 6i, negative 6i, and 36i that we can combine. They're both 30. That doesn't really happen. So, we did this. So the 18 and 12 make 30. The negative 6i and the 36i make 30i. Okay, they're not always going to be the same number. That just happened. Questions about that one? And I just now realized I can't count up there. I have 2 example course. This is supposed to be 3 on that. It's like, why do I have sorry. Okay. So let's just do this last one real quick, and then we have a little exit. So whenever you have a multiplication, you multiply everything together. So we're going to take 1 times both of these. So take 1 times 1, which is 1. Then take 1 times 4i, which is 4i. Then take negative 4i times 1, which is negative 4i. And then negative 4i times the positive 4i, what's that going to be?
Negative 16i squared.
Yes. Alright. What happens to I squared? Becomes negative 1. So we're going to take negative 16 times negative 1 instead. So what's that going to do my 16? Make it positive. Okay. So now I combine like terms. So I can combine this 1 with the 16. So what's that going to be? 17. What happens to my eyes? They disappear. They disappear. Okay, you could write plus 0i. So if you really wanted to, if you really felt it necessary to write something, you could write plus 0i, but usually I just write 17. Okay. I kind of wrote that funny, but does that make sense to everybody? So now, if you flip to that last page of the note packet, there's a little X ticket. So there's an adding, subtracting, multiplying, and dividing. So this is what I was saying. All of these problems look very similar. You just have to look in between it for what you're asked. So when you see parentheses, don't just automatically start multiplying everything. So that first one, notice there's a big plus sign in between it. So the first one you just have to add. The second one, there's just a big subtraction in between, so you just have to subtract. And then the third one, that's where you multiply, and then 4 you have to distribute. Okay? So again, that's the big thing to remember with this. Because once we start working with the multiplication, I know all of them look very similar, but again, just make sure you look in between it. If you see a plus sign, make sure you just add. If you see a subtraction, just subtract. And then multiply, that's when you have to FOIL it.